Good morning, students. So, in the previous classroom discussion topic, we had a discussion on data path. So, how the instruction data path will be there, and what is the five-stage hardware that we have seen in the previous classroom discussion topic. Now, in today's classroom discussion topic, we are going to discuss about uh, instruction fetch and execution in detail. We will see that. So, what are the different types of steps are there in that instruction execution? So that we will see, and just you have to understand what the main difference in previous classroom discussion topic and today's discussion topic is that. So today we are going to discuss in detail about the instruction fetch and execution steps by considering all the five different types of stages in the hardware. Fine. So now we are coming to this topic. So instruction fetch and execution. So the today's lecture objectives are, so this session will develop a students' knowledge on instruction fetching and execution of various types of instructions like arithmetic instructions, load, store, branch, and subroutine calls. So now we will see one by one how this arithmetic instructions are fetched and executed. What is the step-by-step process? We will see that. So consider this instruction, arithmetic instruction, add R3, comma R4, R5. So we already seen that how this instruction will be executed. So one is first fetching the instruction. So after the instruction has been fetched from the memory and placed in the IR register. So the source register addresses are available in the field IR of 27 to 31 bit position. IR one source address will be there, and second source address will be from 22 to 26 bit position. So that means totally from bit position, because IR is a 32-bit register. Students, please try to understand that. So it is a 32-bit register. So 0 to 31 will be there bit positions. So bit positions are 0 to 31 will be there. So among this bit position, so 22 bit position number 22 to 31, they are used for the operand, memory operand values. So these two fields are connected to the address inputs of port A and port B of the register file. So as a result, registers R4 and R5 are read, and their contents are placed in registers RA and RB respectively after this second step. Fine. So in the next step, the control circuitry sets this mux B to select the input 0, thus connecting the register RB to the input INB of this arithmetic logic unit. So at the same time, it causes the ALU to perform an addition operation. So since register RA is connected to the input INA and the ALU produces the required sum contents of RA plus contents of RB, which is loaded into the register RJ RZ at the end of the step 3. So now if you see that the five-step process here. Okay, so we already discussed about there are five steps in the instruction execution, and these five steps you can write like this. The actions you can write. So first, the contents of PC is loaded into the memory address, and then we will read that memory, and whatever that we have in the memory data, it will be loaded. IR is loaded with that memory data, and then the program counter is incremented to the next instruction. Program counter is incremented to the next instruction. So then in the second step, the what are the actions are carried out here? We have to decode the instruction. So once you decode that instruction, so the RA register contents R4 is loaded into the first operand intermediate register R4 RA, and second intermediate register RB, the contents of R5 is loaded. Then in the third step, ALU operation will be carried out. So that is nothing but contents of RA and contents of RB is summed up, and the result will be stored in the RZ. So then after that we have to store that value contents of RZ value into RY. And then in the fifth step, the contents of RY is transferred to the processor register R3. So these are the five steps that will be or five actions that will be carried out when we are executing this arithmetic instruction. So in step 4, the multiplexer MUX-Y will select input 0, thus causing the contents of RZ to be transferred to RY. So the control circuitry connects the destination address field of the add instruction. So IR, so the bit position 17 to 21. So to the address input for port to C of the register file. So in step 5, it issues a write command to the register file, causing the contents of register R5 to be returned to the register R3. So when that instruction is decoding, so generally we are making use of this instruction decoding. So that instruction decoding is done based on different types of operands. For example, if they are the register operands are there, then here 0 to 16 bit position. So totally 17 bits are opcode value. Then 17 to 21 bit positions acts as a register destination register. 22 to 26 register source operand 2, and 27 to 31 bit position register source operand 1. So that is the reason. So this is the instruction encoding we have used in this particular example, add R3 comma R4 comma R5. You see here the first operand, second operand is 22 to 26 and 27 to 31, and the result will be encoded here. This is the 17 to 21 is actually the result of destination register. So if we have an immediate operand is there, okay, if that immediate operand is there, then we will make use of this as a instruction encoding. So 0 to 5 opcode and 6 to 21 immediate operand value, 20 to 26 destination register, and 27 to 31 bit positions acts as a source register. Okay, then if we have a call format, that is the subroutine call format is there, then the instruction will be decoded encoded like this basically. So 0 to 5 gives the opcode values, now 6 to 31 gives the immediate value of the subroutine call, return address value will be given here. So these are the instruction encoding formats generally used when we are making use of that particular instruction. So 17 to 21 bits in the IR register will act it as the destination operand here if you take it as. Okay. So that is connected to the port C of the register file. So next, coming to the second category of instruction, we will see load and store instructions. So this, for example, if you consider a instruction load R5 comma X of R7. Any students please tell me what is the addressing mode we have used in this instruction? So that is nothing but what indexed addressing we have used here. Fine. So when you want to perform this load this instruction. So what are the sequence of actions that are performed by the data path or processor when this instruction has to be executed? So these are the sequence of instruction execution steps. 5 steps are there here. Generally, 5 step in process for instruction execution is used. Okay. So in this case, the address of the destination register is, what is that address of the destination register is given in bit fields IR of 22 to 26. Okay, so this is the instruction register we are using in the bit field of 22 to 26. Okay, 22 to 26. This is what the format we have used here. Immediate operand format here. Immediate that is 22 to 26 is used here. Okay, the control hardware connects this field to the address input corresponding to the input C of the register file. So in both these examples, the memory address is specified using the index mode, in which the index value x is given as an immediate value in the instruction. Fine. So that is nothing but here first in the first step. So when we want to execute this load instruction, so contents of PC is loaded into the memory address, read the memory, and then memory data will be loaded into IR. Then program counter is incremented by 4, and then second step decode the instruction. So the contents of R7 is loaded into RA, and then RZ is assigned with content of RA plus immediate value of X, and that gives it this RZ. So the contents of RZ will be the memory address, and from this memory address we have to read the value. So that is memory data should be loaded into ry, and then the contents of ry is loaded into r5. So this is what the sequence of 5 steps that will be done for this load instruction. So coming to the store instruction, so the result of this store instruction, if you see that store r6 comma x of r8, here also in the index register we have used index addressing mode, we have used that. So we have to store this the contents of r6, we have to write into x of r8 memory location. So first we have to read the instruction. So the contents of a pc is read into the memory address, and same as usual, load instruction first point. Then the second step is that decode the instruction. Once you decode the instruction, contents of R8 will be read into RA. Then contents of RB will be read into RB. Then RZ is computed as RA, contents of RA, okay, plus immediate value X. Then contents of RB is read into RM. Then memory address RZ contents will be read into memory address. Then RM contents will be read into memory data, and then we have to write that memory. So then in the fifth step there is no action. That is the store instruction basically. So now the reflections part one here is that what is the difference in load and store instruction execution steps from the arithmetic instruction. Fine. So comparing with this load and store instruction, in the store instruction there is no action in the fifth step. Fine. So now the third category of instruction we have to see is the branching instruction execution. So branch instructions will specify the branch target address relative to the program counter. So a branch offset is given as an immediate value in the instruction, and it is added to the current contents of the PC. So the sequence of steps for implementing an unconditional branching instruction is given in this particular figure 5. So here unconditional branching instruction we are taking here. So after this reading of this PC value into the memory address, and then read the memory, and then memory data will be read into IR, then program counter is incremented. Always for all instructions this first step is as usual. Then in the second step, decode that instruction. So once you decode that instruction, here we are specifying that branch target address. We are specifying related to the program counter. So that's the reason the program counter value is incremented with the branch offset. So PC is incremented with PC plus branch offset. That is what only the thing we are doing that. So after the instruction has been decoded in step 2, multiplexer mux increment select the branch offset in the IR to be added to the PC in step 3. So this is the address that will be used to fetch the next instruction. So execution of a branch instruction is completed in step 3 itself. So no actions is taken in step 4 and step 5. This is unconditional branching we are calling it as. Then next we will see the conditional branching. So generally when we are using the conditional branching here, for example, branch if contents of R5 is equal to contents of R6, then we are branching to the loop. So once you see this conditional branching instruction, so the results in a branch if the contents of register R5 and R6 are identical. So when this instruction is executed, the register contents are compared, and if they are equal, a branch is made to the loop. Fine. So the first step as usual. Okay, and then we are decoding the instruction. Then contents of R5 is read into RA, contents of R6 read into RB. Then we have to compare RA to RB. So if RA contents of RA is equal to RB, then the program counter is incremented. That is the PC is incremented with PC plus branch offset. Okay, and similar to that unconditional branching in this also step 4 and step 5 there is no action. So this is what the branching instruction execution is. Now the last category of instruction execution is subroutine call instruction execution. So subroutine calls and returns are implemented in a similar manner to the branch instruction. So the address of the subroutine may either be computed using an immediate value given in the instruction, or it may be given in full in one of the general purpose registers. For example, consider this subroutine call register R9. So which will call a subroutine whose address is in the register R9. So the contents of that register are read and placed in RA in step 2. So during step 3, multiplexer mux PC selects its 0 input, thus transferring the data in register RA to be loaded into the PC. Fine. So memory address, PC is loaded, memory, and that memory data IR. So this instruction first step is as usual. Second step, decode the instruction, then contents of R9 will be read into RA. Then PC content will be temporarily stored in PC temp register. Now the PC is loaded with the contents of RA. So the PC contents of PC temporary register will be stored in RY register. Then the contents of RY is stored in register link. So this is the one register that is used when we are making use of this subroutine call. So the contents of RY is loaded are stored into this register link. Okay, so link is a register used in this subroutine calls. So now the lecture level practice problem is that, so you are supposed to write the steps involved in execution of the following instructions by considering this 5 stage hardware. So if you are executing div R3, R1, R2, so what are these 5 steps and their corresponding actions you have to write it. Similarly, this is a store instruction. For these two instructions, you have to write it. Fine. So any doubts you have? So we have seen all these different 5 different categories of instructions. We have seen how the instruction executions steps corresponding to that 5 steps and then corresponding actions. We have seen that. Fine. So any doubts you have? So if you don't have any doubts, now I will stop this session. Okay. Thank you. Thank you, one and all.